Next. Sorry.
So today we are going to start a new module, which is denial of services. DoS. Okay. So in denial of service, our goal is to make these services unavailable for the victim. Okay. So goal to make the victim traffic busy or on hold on the network, and make services unavailable. This is our goal. Now, how will we do it? So in DoS attack, we put our victim traffic on hold by sending the huge amount of packets at a single time. So our target is going to be busy. Let me paste it. Now can you see here? This is the malicious actor. These are the hackers. And here is our victim, a regular guy. Now we're going to keep sending huge amount of packets at the server to make the victim traffic busy. Can you see? There are large amount of packets and large amount of traffic on this bandwidth, on the hacker's bandwidth. And here there is a low traffic, or let's just say we are trying to keep the user busy with these activities. Okay, making the service unavailable for the victim. Okay, so same, this one will be DoS attack. DoS attack. Now same, we have another thing, same attack known as DDoS attack, which is distributed denial of service. Now, what happens in distributed denial of service? Hacker is going to use a botnet, which is a compromised zombie. Hackers will have the army. Hackers gonna have an army of these botnets. Okay, these are compromised zombies, compromised device on the network, and they are going to each and every task the attacker commands it. Okay, so now how will attacker will command it? There's gonna be okay. Nothing. This is our hacker over here. Now hacker, this is this is our botnet. Now, with the help of this botnet, hacker will try to control this device, compromised device. It is another compromised device, compromised by hackers, and this botnet is going to be command and control center for the attacker. So attacker first will command to this botnet, okay, this command and control, and then is gonna distribute the attack. I mean, they distribute the command to each of the each and every one of this botnets. And what they will do, okay, see, zombies can be of any range, okay. Even there are hackers who have thousands of armies, thousand armies of these zombies. They will attack, okay. See, attacker over here is trying to communicate to the botnet with the help of command and control center. Okay, this is another device. Okay, hacker could be anywhere in the globe, and these are distributed zombies all around the world. Okay, so hacker will use this command and control center that will pass the commands to these botnets, and these botnets at the same time at the same frequency they will try to attack the victim or the targeted. Okay, targeted service. Again, the intention also over here is to make services unavailable for the victim, for the user. Okay, so now also this, let me give one example. This services, okay, this is our service. This could be any of this a booking ticket service, or any server, or any shopping site. Okay, this could be anything. This service could be anything. But how the attacker is really attacking this? So when the attacker do a DoS attack, okay, execute the DoS attack, all the users using these web services, okay, all the users, all the users over here using these web services is gonna let's just say they are just their traffic gonna be hanged in between. Okay, the services and the traffic which they are gonna receive will be slow. So because of that, again, the users will go to different sites, different booking ticket servers, different shopping sites. So in short, attacker is damaging company reputation and finance, right? Because all the users who are using these kind of services, okay, these websites, shopping websites or servers, now every user using these booking tickets and servers and shopping sites are gonna be directed, okay, redirected to another services. Of course, if the service is not loading, you're gonna visit another site, right? So the company owner will receive a damage. It can be the reputation of, okay, hackers are damaging the reputation of the company. You're gonna be giving the reviews that this site wasn't working. This website is uh, take for year to load. Okay, so you're gonna be having bad reviews on that particular company. So in short, attacker is damaging the company's reputation, and also it is damaging financially, because if you're not gonna purchase anything from that website, the losses goes to the company owner. Okay, loss of company owner. Now there are different types of DoS and DDoS attack. Okay, types of different DDoS attack. Again, the goal even here is to send flooded with packets to the target and make services unavailable. So first we have volumetric attacks. Okay, just give me a second. Okay, let's go from bottom to up. Okay, application attack. Okay, this is the layer 7 of OSI model. Okay. Layer 7 of OSI model. Now, in application, all the application services like HTTP, HTTPS, or any remote services we can target. Okay, all the application services, which are all the application services. Okay, layer 7 application services running, we can target it. Okay, it can be DNS, it be HTTP, HTTPS, or LDAP, anything. We can target it. Now, second comes the, let's take over here, volumetric. Now, in volumetric attack, we are uh, we are consuming unnecessary bandwidth. Okay, unnecessary consumption, unnecessary consumption of bandwidth. Okay, so example, UDP or ICMP packets, we're going to be sending, the packets with a large number of data size. Okay, we're just using or wasting the bandwidth of the target. Okay, protocols, UDP or ICMP. Let's go for quick. Let me open my CMD. Okay, when I do ping 8.8.8, okay, oh yeah, which is Google. Okay, let's just say ping google.com. Okay, see, can you see the packet we are pinging Google? This is the IP address of Google, and this is the bytes. Okay, 32 bytes of data. Each packet of 32 bytes. Okay, there are four 32-byte packets which we are sending it to the Google. Now let's just say in Google, I'm giving it a length -L 65,500. 65,500. Okay, can I do it? Session time request. See, kind of. Again, go for a smaller number. See, again, timed out. Go for even smaller number. Can we ping? See, timed out. Because Google load balancer, okay, the load balancer and the firewalls which Googles are having are blocking my request. Okay, so what this means is, oh yeah, we are when I do ping just google.com simply. Okay, I'm getting it right. But when I do ping and I define a length, okay, whatever it is, okay, whatever length I'm defining here is not is getting blocked by google.com. Okay, this is -L for length. Okay, that request is getting blocked by Google. How so? Is because let me see if I have the bandwidth. Yep. Okay. So why is it blocking? Is because this refers to the ping of that. It, it is a type of DoS attack. Okay, it's a type of DoS attack where if we define our length, okay, packet size, packet size of more than 65,000. Okay, 65,500, then it is considered as ping of death. Okay, let me paste the picture. Now, as you can see over here, these are my IP fragmented packets. Okay, this is my IP header over here, ICMP header, 8 bytes. But when I define a, a particular packet, okay, with a large number, can you see over here, greater than greater than or equal to this byte, okay, 65,508. Okay, If I just increase a single 8 byte, then it is considered a thing of that, and it is going to be blocked because we are breaking the rule. Okay, we are breaking the rule and we are exceeding our RSE limits. Okay, we are exceeding ICMP RSE limits. The what is RSE limit is, it is a rule. Let's just say it is a like a firewall rule. We can only send certain amount of packets. So when we exceed it, it becomes the ping of that. And most of the modern technology, okay, EDR, IPS, IDS, is going to block it because it is considered as DoS attack. Can you see? These are the IP fragments. Okay, IP, all the packets are getting broken down into small number of packets, and they are sending and they are attacking to a targeted system with a byte size over here. See, this is our actual packet. Okay, actual data size. But we are adding this byte over here, which is the DoS attack exceeded parts. Okay, exceeded ICMP RSA limits over here, 65,535 bytes. Okay, when we exceed this byte, then it is considered as ping of that. That's why Google was blocking our request. Okay, so any doubt here in ping of that? Hello, hello.
Hello, sir.
Yeah, man.
Yes, sir. Are you guys there?
Yeah,
Yes, sir.
I'm listening to you.
So, do you have any doubt understanding ping of that? Is it working clear?
Yes,
Yes,
sir.
sir.
Okay, let's move forward. Okay, so now third is
I
our
think we are with you.
hello. Yes, is anyone having doubt over here? Hello, please explain DDoS. Okay, now see. Okay, guys. So when I'm covering some any topic, okay, please consider on that. Okay, so we don't have to come again and revisit the topic. So DDoS attack. Okay, it stands for distributed denial of service. Why why the term distributed? Because hacker is going to have an army. Okay, hacker is going to have an army of zombies. And what are these zombies? Zombies are compromised devices. Okay, already already infected by the attackers, by the hackers, and they are in control of the attacker. This is our hacker over here. Yes, Mrs. Shahab, you have raised your hand.
Kevin, sorry to distract you, but how we create these zombies?
I'm not getting your point.
Mal I
Means, yeah, the
malware need to be installed.
Okay, okay. Listen. Let's start from the beginning. See, hackers is going to infect a particular target. Okay, in a network from here. This is the network. Attacker, this is our attacker. Okay, these are the victims. Now, attacker will infect this with any malicious code. Okay, any malware, spyware, adware, anything. Okay, with any attack services or any attack vectors. Now then, the system will be getting on infected. Okay, this system will infect this system. This system will infect, like vice versa. This, then this, then this, then this. Okay. Now, what the attacker will do? Attacker is going to put all the system in one particular network. Now, attacker is out of the picture over here, and all these over here becomes the zombies, right? Okay, all of these become zombies because they are infected by the malware which the attacker has provided. Okay, which attacker has installed on these systems. So all of these victims, all of these devices are infected by the attacker's malware, right? So attacker can control these systems at any time and anywhere, right? Mr. Shah, are you getting my point? So
So it's clear. Okay.
they become command and control center for the attacker. So at any time, any long as there is any residue, attacker can control these ports. Attacker can command it, and they are
Send the packets.
forced to follow this packets. Okay, forced to follow the commands of the attacker because they are in control of the attacker. Now, again,
Okay.
how DDoS will work? This is the zombies. These are the zombies. This is our botnet. Okay, this is our botnet. Botnet is also a zombie. Okay. Now attacker first will try to command this. Okay? This botnet is also a command and control center for attacker. Okay. Let's just say this attacker is in uh, Colombia. Okay. The attacker is in Colombia. This botnet is in India, and all these zombies are anywhere. Okay. So they are anywhere in the world. Okay. Then from Colombia to India, then to India to these botnets. Okay. From Colombia to India, and from Indian to these botnets. Then these botnets will try to send large number of packets. Okay, large number of packets onto the target. And the victim, okay, over here, let's just say this is our user, genuine user. Okay, this is our genuine user. When user will try to access the service, okay, when user will try to access the service, it is going to be on hold. Okay, the reply is going to be on hold because the targeted, okay, service over here is busy replying to all these botnets, all these zombies. So the actual packet, okay, actual reason and actual packet of the user coming from the genuine user is going to be on hold because the network and the services is, are busy replying to these zombies. Okay, so this is how we are going to be making the services unavailable for the user.
Okay, Kevin. Just a little bit more question. Kevin, all these zombies will ping the server, the attack whom we are attacking.
Yes.
or accessing it? What are
Yes.
they? What they're doing?
Actually, they are going to be pinging. Okay.
Okay.
If I put a command, let's just say this is my command. Okay. This command will be received by this botnet, and that command is going to be passed to all of these commands, all of these uh, victims. All of these zombies. Okay, compromised
Okay, sir.
devices, and
Okay.
that compromised devices will be running that command, and they will be executing onto the real network, onto a real server, and that particular server will be hanged because of course it is using, we are giving a DoS attack over here, right? So the genuine user having a genuine request to access that particular service, it will be on hold, right? So in short, okay, in short, we are making the user, okay, making the services unavailable for the user, right?
Okay. Sir, if the ICMP is blocked, then the DDoS is worthless.
We can use UDP, as I told you over here. There are
Okay.
two
Okay.
types. Let's come back here. We have two packets, ICMP and UDP. And ICMP, most of the company cannot disable ICMP because ICMP is uh, let's just say ICMP acts as a doctor for the networking devices. If any device is not working, if any device is unreachable or it is out of network, only ICMP can uh, give you the diagnostics. Only the ICMP protocol can give you the diagnostic of that particular device. If it is well, if it is connected to a network, if it is alive or dead, okay. Only the ICMP can give you the package. So most of the organization, they put security and some of them disable the ICMP. Okay.
Yes, sir. Thank you. Thank you.
Again, Kevin, like now, even our clients as well, what they are doing, they are even like restricting that east-west traffic. So which means like within data center, one VM
Yes.
can talk to another VM, even on ICMP as well.
Yes. This is see, VM is in a particular network. Okay, it is in a virtual network, and that virtual network is getting uh, internet from our host. Okay, from a host.
Correct.
So in that particular host, a VM from VMs can communicate to another VM easily because they are in a particular host and they are in same network.
No, even now, they are following zero trust model, which means within a host as well, one VM cannot communicate to another VM. This can also be restricted now.
Yes, that is known as egress and ingress pass filtering.
Yeah, so there are some like I hope you heard about this NSX and Cisco ACI.
Yes,
Cisco ACI and VMware NSX. So these are providing that distributed firewalling, which means like even within a same network and same host, one VM cannot talk to another VM without the policy.
yes. So it is like filtering, that you are filtering some packets and filtering the
Filtering at VM level, VM NIC level.
so it is known as egress and ingress filtering. I'll come to that topic when
Mhm.
once we are done.
Yep.
Okay. So Mr. Chirk, now now see, attack hacker will attack thousands or hundreds of devices in the network, right? Making them vulnerable and making them uh, controlling them. Okay. and it will have another attack, no, I mean another attack machine over here, which is also known as zombie or a botnet, you can say, and it will be acting as the command and control center for the attacker. So the process is from a hacker, the command will go to the command and control center. Then the command will go to the zombies. Okay, all the army of the zombies. Okay, and from that, all the zombies will attack. I mean, will execute that command. Okay, run the command and make the service unavailable for the user, damaging the company's reputation and making the company owner a loss. Okay, Mr. Chef.
Sir, thank you. It's clear.
So again, coming back to the volumetric attack. Volumetric attack is we are consuming unnecessary bandwidth of the ICMP and UDP packet. Even if the ICMP is blocked, okay, ICMP packets are blocked, services are blocked, we can use UDP, and we cannot we cannot deactivate UDP. Even if you are doing UV uses Kerberos is thing and LDAP is one thing. Okay, we cannot disable UDP fully. Okay, so Kerberos is a thing which we use, and LDAP is a thing which we use. Alternate UDP. Now, ping of that is known as the exceeding our ICMP RSA limit. Okay, ICMP packets are having some limits, and if we break the rules and if you exceed that limitations, then it is considered as ping of that. Okay, so the packet size will be only 65,500. Okay, and if we exceed it with a single byte, okay, let's just say with a single 8-bit, which is 1 byte. Okay, 8-bit is equal to 1 byte. So with just 1 byte, our packet is going to be considered as the ping of that. It is going to exceed the ICMP RSA limits. Now, third one, we're done with the application, we are done with the volumetric. Third one comes the protocol. Protocol attack. Okay. And now, in protocol attack, we are going to be using protocols like synchronization, acknowledgement. Now, synchronization is used for the establishment, of connection. Okay. ACK is used for the conformity, of the connection. Okay. And comes the fragmented packets. Now, let us go for this Java server. This is the user, right? Now, normally, how the TCP three-way handshake works. Okay. Now we are going to establish the connection, right? Which is with the help of TCP handshake. Now this is the SYN packet. So normally we will be getting the acknowledgement for that particular SYN packet. Okay. Um, give me a second. Give me a second. First, we send the SYN packet. Then we receive acknowledgement. Plus SYN. Okay. Then we send acknowledgement, right? But in DoS attack, okay, in DoS attack, we're just going to send SYN replies, okay, SYN packets. We're just going to be sending, just going to send SYN packet to the particular server, okay, and that server will get busy replying to those SYN packets with the acknowledgement packets, okay. The server will get busy replying to these SYN packet with the acknowledgement. So now, when a genuine user will try to approach, okay, when a genuine user try to approach with the SYN packet with its SYN request, it will be on hold. Okay, that particular SYN request will be on hold because the server is busy replying at packet, the acknowledgement packet to the SYN packets over here of the attackers. So services for the user, for that user, is going to be on hold, right? So this is how SYN attack, SYN DoS attack works. Okay. Any doubt here?
No, sir.
So again, our intention is to keep the target busy with sending large amount and various packets of the SYN packets. Okay, SYN packet, and the server will be busy. Server will be busy replying to that particular SYN packet with the acknowledgement request. Okay, and in that interval, when a genuine user tries to connect to the server, then his request will be on hold.
Kevin, so what if in case if organization is blocking DDoS, then is there any way to bypass those devices?
I'll let you know. Just please stay on the topic. Once we
Okay.
are done with this, once we are done with the attack part, we're going to hop on the defense.
Okay.
Okay. Please have some patience. Okay, let me get the connection. IDP. Okay, this is my Kali Linux. First is the application attack. Okay, we're using tool. Low risk. Okay, first attack is going to be application attack. Okay. First is actually volumetric, but I covered application because it is small. I mean the topic is small. Slow risk. Now this is my Windows. Okay, it has IP 10.0.2.15. Okay, and this has the internet over here. Okay, internet. What I'm gonna do, see, Perl slowloris.pl. See, why am I using Perl command over here is because that slowloris is written in Perl language. Okay, this is a Perl script. It is written in Perl language. So we are using Perl slowloris.pl dash DNS domain name service. We're going to give a domain name. Just say Tesla. Okay. Now, highly recommended. Please don't do this. DoS attack is a crime. Okay. Now, once I run this command, can you see? Building sockets. See, all the TCP Is. Can you see? This is my source IP address. Okay. Now, let's quickly go to Tesla.com. Over here, I have Tesla.com. Let me refresh it. Let's go Tesla.com. Okay. Can you see? Is it loading? It is loading, but is it giving any results? Hello, are you?
Yes, sir, we are viewing your screen. It's
So is
loading
it
a
giving
little bit slow.
No, it is loading, not slow. It is not even loading.
Okay.
So let me end the attack. It on will. Now see over here. Our source or the destination. This is our TCP DNS request. Or right? Why DNS request? Because we are giving it an IP address over here. We were giving the host name, okay, domain name, and that domain name will be converted into the IP address. So we are using DNS protocol over here, and TCP is for the synchronization, acknowledgement, and CNAP. Okay, because once we are done with the handshake, then only that request and then the site will get loaded. Site will be loaded. So this is how slow loaders work. Okay, slow loaders. Okay, Perl command to run the slow loaders Perl script. It has DNS. Give a domain name over here. Let me take a screenshot of it. Now let's go for the volumetric attack. Now, tools for the volumetric will be Xping 3. Now, again, a difference between slow low risk and Xping 3 is Xping slow low risk comes in application attack because we are over here. See, this is our application. Okay, it is a web application, right? So we are attacking the application service, HTTPS. We were attacking that. Okay, so we were attacking an application, and over here we are using or consuming the bandwidth of the network. Okay, so this is known as volumetric attack. So as ping 3, I want a count. See, now packet count. How many packets do I want to send? Let's just say 10,000. 10,000 packets. Now hyphen D. Hyphen D is for the data size, packet size. Okay, let's skip 500. Okay, now I want random source. So my IP address will be hidden. Xping 3 will be using any random source IP, random source IP. Okay. If you want to spoof, we can also spoof our target or any destination server. Now, random source and now mode.
Sir, what is C for?
C for count. How many packets do you want to send? Packet count.
Okay.
Okay. D is for the data size, packet size, and random source. We are not using. We are spoofing our source IP address. Okay. We'll be using different IP addresses, any random IP addresses.
Okay, sir.
Now mode. Mode is UDP. 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 And port. P for port. 53. Okay. Now 10.0.2.15 IP address. Okay. This Spring 3 is same as Nmap. Okay. Now go to our Wireshark. Observe over here. Can you see DNS request? See the source. Let me stop it. Can you see? This is the source IP addresses, and this is our destination IP address. Now, source IP address is getting changed by each and every request. Okay, it is getting changed, but the destination remains the same. Now, protocols which we are using is DNS, and first we use the ARP to get to know devices in our particular network. We used ARP. Okay, then we use the DNS. Okay, so let's Can you see malform packet, malform, exception occurred, DNS query. Can you see domain name service? This is the query, and this is a malformed packet of DNS. Let's take a screenshot. Okay. This is our command. Wait, let's try with this. Now let's do it for ICMP. Okay, ICMP. Now in ICMP, you don't have to define any port because ICMP is just a diagnostic message. Okay, so it's okay if you just are going to ping. If you want to provide any port, okay, you can ping a particular port. Okay, 22 or 21, any port, but it is okay to ping. Sure, yeah. Sure. Or protocol ICMP. We have different source. We have same destination over here, and I've told you about the app. You open stop it. Any packet see over here. ICMP Internet Control Message Protocol. Okay. Type is echo. You can see the checksum, identifier, sequence number. Okay. So this is how ICMP packet works. Okay. Okay. Tool use Spring 3.
So one question.
Go.
Like if we are doing ping with port number, so will that hit on the service or like
See,
on the ICMP? It will go.
actually it will hit the port, right? Because your services are running on that particular port. So either you can define the port or you can uh, go without the port.
Like in the second example, we just mention this ICMP as an protocol,
Yes.
correct? And you told like we can also specify like after ICMP we can also specify the port number.
Yes.
So what does that mean? Like will that hit ICMP packets on
Yeah,
the
I said
service?
it will ping that particular port. Okay. It will only ping that particular port.
But how, sir? How port?
ICMP, see, ICMP is just a diagnostic message.
Yeah. So this is protocol, like ICMP is an protocol.
So why am I saying this? Is because some of the tools when you define, even if I define any port over here, it won't give me any error. See,
Hmm. But what exactly,
got
can you run Wireshark again? Like,
yep. See, over here, what I wa-
sorry.
what my point was, even if you give define any port,
Hmm.
not going to give you any error over here, and that ICMP will hit that particular port only. Okay.
But ICMP is a like layer 3 protocol. How it will hit that port number? So that's the reason, like, I'm asking, like, I'm confused then.
Okay. Also, okay. That
ICMP is layer 3 protocol, no, sir. And
see
port numbers are layer
that
4.
won't any that won't hit any port over there. Okay. This is just like for beginners. I said if you if even if you define any port over here, it won't give you any error. But the ICMP will only hit the particular network if that particular host is alive or not. That is the diagnostic message. Can you see over here? ICMP from source to a destination. Okay, Mr. T. Are we clear now?
Yep. So that means it is just sending that ICMP packets.
Yes. See, ICMP is just a diagnostic message.
Hmm.
It will just tell you that if the port, I mean, if the host is alive or not, if the host is responding to your message or not.
So,
Consider ICMP as just simple hi and hello.
so
Uh,
no,
you
that
let us say, uh, if I see you in in a college, okay. If I see you in my college, I just say hi, how are you? That's it. We are done.
no, but after specifying port, so there is no significance of that.
No significance. I just said for the beginners, like see over here, it was UDP with the port 53, right?
Yep.
So you can also do UDP packet, okay? UDP packet with port 22.
So that will make sense. Like, since TCP and UDP both are like transport layer protocols.
See over here, all the UDP ports are getting
Hmm.
sent, right?
Yeah, right, right.
Yeah. So consider ICMP is just a simple hi hello between the host, between the networking devices. Nothing else than that. It doesn't contain any meaning in that. It doesn't have any message in ICMP. It will just tell you that if the host is alive or not. Just a diagnostic message. So all the SNMP packet, okay, SNMP framework is going to be uses the ICMP port protocol. In if you remember in previous section in previous lectures, we we covered the topic animation, and that animation then I've thought about the SNMP animation part. If you were present in that particular lecture.
I was
So
not there, but I understood what you are saying.
okay.
Hmm.
So in that as SNMP it has one agent and one manager. So SNMP is simple network management protocol. Okay, and that manages and all the networking device. Okay, and it uses ICMP protocol to get the information about the host to get the diagnostic.
That again, like, uh, I do have like worked on this monitoring tools. Okay. But again, sir, that ICMP is one of the way to monitor the devices. But information we gather mostly from this SNMP protocol, port
Yes,
number
because
161.
see, let's just say okay, this is our two device. Okay, one one is up and one is down. Okay, so this PC over here, this networking devices won't send any message. Okay, won't send any message that if it is down or not. It is going to SNMP. SNMP is going to manage it through ICMP, and that ICMP message will let the SNMP protocol know that this particular device has been down. Okay, that's why we use ICMP or the ping command to know if the host is alive or not. Okay, Mr. Deep?
Yes, sir, but still, SNMP will do that polling. I hope you heard about that OIDs.
Yes. So
It will poll
see,
the device.
you can ask freely. What is the actual uh, problem that you are facing?
So what I am no, so that was cleared. That previous one, that ICMP with the port number. Okay,
Yes.
but
So anything here?
fine.
See,
SNMP is
just
fine, right?
go through a networking. Okay, networking your SNMP. SNMP stands for Simple Network Management Protocol. Okay, SNMP. And to manage the particular network, SNMP uses ICMP protocol to get the information about the host, about the networking devices present on that particular network. So if the device is alive, if the device is not working, if the device is out of the network, it will get all these information through ICMP. Okay, and with that ICMP packet, okay, ICMP message, it will be sent to. There are two things is that in SNMP agent and SNMP manager. Okay, that ICMP will come. Okay, if the host is down, it will go to the agent. Then agent will request the SNMP manager saying uh, what should be done now, that if the host is alive or not. Then manager will resolve that particular issue and reply to the SNMP agent. Then SNMP agent will do the working. Okay, and it will update MIB, which is managing information database or managing information base. Okay, each mm, oh yeah, see, now the agent device. Okay, agent care could be anything. Okay, devices, routers, switches, and see SNMP agent, SNMP manager. It uses ICMP see SNMP responses and SNMP commands. Okay, they uses ICMP between them. Okay, and then if the server, I mean the device, okay, any device in that particular architecture in that network is down or facing any problem, then IC this message is sent to the ICNM SNMP agent, and then SNMP agent goes to the manager, asks for the solution. Then can you see here the command SNMP command goes to the agent. Then agent updates the database MIB database. managing information base. Okay. Okay, Mr. Deep. Are we clear now?
Yes, sir. Yes, Kevin. It's clear. But anyway, sir, this is like off the topic,
See,
correct?
why? Yes, it is off the topic because of
Mhm.
the question. See, why? And please don't message me directly. You can message it to everyone so everyone can see your query. So why they will use 161 protocol? I mean port 161 is because SNMP works on port 161 and 636 two ports.
Correct. Correct, sir.
Uh, my writing is really bad.
But it is like we are able to understand.
It's okay. So 161 and 636.
Correct.
These two are the products which SNMP is going to be using. So ICMP is just dead end protocol. Okay. Now coming back. Okay. So any doubt over here? HPing protocol, guys.
Nothing from my side, sir.
Anyone else having doubt? These are the commands. Please try it. Now we are moving forward to our protocol attack. Protocol DoS attack. Okay. Now protocol DoS attack. SYN. We can use SYN acknowledgement. We can use these fragmented packets. Okay. Just search SYN flood. Okay. So we have here auxiliary module. So use auxiliary DoS SYN flood. Okay. So options. Now set our host to standard 15. And see, to bypass the defender, to execute this attack, bypassing the defender is important. It's okay. We just want to see this. See over here, we are sending TCP, large number of TCP packets. Can you see onto our target? So how the attack will happen works over here. When I go to any website, okay, if I do anything over here, this is admin, this will get stuck. Okay, this will get stuck. It won't load. Okay, but we have defender over here. Can you see over here? We are just sending SYN packet with sequence number 0. Can you see all these packets? Just SYN packets. We are not getting any SYN-ACK or acknowledgement packet. Just SYN packet on port 80 with sequence number 0. Okay. Packet length is 64. Protocol is TCP. So this is the SYN packet. We are using a tool. Tool used. Okay. Now same goes for the acknowledgement packet and same goes for the fragmented packets. Now what are fragmented packets is, this is my now what attacker will do. Fragmented packets. Now attacker will dissect all the packets. Will dissect all the packets to a small form. Okay. And then okay, it will cut all the uh, numerous huge amount of packet into small bits, and then it will send to the victim. Okay. So it is like slowly you are attacking something. Okay. So all the packets like coming. Okay. Slow packets. Okay. Slow packets. It will going to disrupt the flow. Now we can also port one will be multi-vector, multi-vector, which means combining volumetric combining volumetric protocol plus the application. So combining all of these is known as multi-vector attack. Now, in that it is also known as flashing. Flashing, which is hardware attack. Now, in this hardware DoS attack, we are going to disrupt the flow of particular hardware. Let's take an example of a car. Okay, let's just say this is our car. Okay, it has functionalities, functions of that car. Okay, right, left, forward, backward. So these are the functions of this the particular car. Now we are going to disrupt the flow. Now let's just say instead on the right, I'm going to put forward, and in backward, I'm going to put left, and vice versa. Okay, so we are a goal over here is to play with the hard drive, hardware drivers. So whatever the driver, the hardware driver is, we are playing with it. Okay, instead of right function, we are putting forward. And instead of forward, we are putting right. Okay, and instead of left, we are putting the backward. So this is how we can play with the functions of the hardware, and it is known as flashing. And let's see some Windows Windows.DOS tools. One Windows is high bit iron cannon. Now, why am I not showing this is because running this and downloading this command, this tool is a crime. Okay, I'm just gonna show it to you. Okay, high orbit iron cannon. Okay, these are the some of the Windows operating systems. Okay. One is high orbit iron cannon, and one is LOIC. LOIC, high orbit. One is LOIC. Let me paste the picture. Now, using these tools is really simple, but it's highly recommended that you don't try this. Okay, it's a highly not recommended because it's a crime. These tools is a crime. So simple. Just come here, paste the URL. Okay, and oh yeah. Hello, can you hear my voice? All of you. Hello.
Yes,
Yes,
sir.
sir.
Yes.
Hello.
Yes, sir. Hello.
Hello.
Hello. So can you hear us?
Okay. Yes. Now I can hear you guys. Now, see, using these command, I mean these tools is really easy. Just put in paste the URL, lock the screen, and it will guess the IP address for that particular URL. Okay, and just you can make the TCP header. You can do the select the port. You can select the method over here and number of threads and speed. Okay, speed. So this is the TCP headers. Okay, you can change it, you can modify it, and you can attack. Okay, start flooding and stop flooding. So using these tools is really easy, but please don't try this. No. So defense. Defense method. First, we can use log analysis. We can use log analysis to check the traffic. Okay, to monitor the traffic, like uh, what particular data is in the log. Okay, is in the network. We can do funneling. Let's explain funneling. Second thing is deep packet inspection. Okay. DPI, deep packet inspection. Egress and ingress. Egress and ingress filtering. Second is honeypot. Okay. Sixth, we can use header analysis. Okay. Now, funneling is a process where we have a server over here. And let's just say there is a huge data which is coming to the server. Now, what the server will do, okay, server will break down each of the that packet into each smaller ones, okay, into the smaller ones, and okay, it will cut down, okay, into the big packet into a smaller one by its own algorithm, okay, by its own algorithm and its own particular timestamp. So it will help the server to get all of these packets, okay, at once, but won't uh, won't be able to DoS. Okay, so this is known as funneling. And egress and ingress packet filtering which means like we are going to filter like which and how the attack vectors are going to be uh, patched. Okay, what services uh, and from what host, which host and which port the traffic could get in and could get out. Okay, honeypot. Honeypot is the trap for hackers. Okay, let's just say we have a honeypot over here. We have a honeypot over here. When hackers attack this honeypot, okay, considering it as a victim or as a networking device, what a honeypot will do? Honeypot will get the attacker trapped into that particular system, and from that we can do the analysis and we can catch the attacker. This is the working of honeypot. Okay, uh, header analysis. Now let me paste the picture of it first. So, now this is our TCP header. Now we can analyze the TCP header. If that contains the sequence port number, we can check. Okay, sequence port number, destination port number, sequence number. Okay, we have talked about the sequence number, acknowledgement number. Okay, SYN and SYNAC numbers over there, and offset bit, reserve bit, and all the flags. Okay, push flag, reset flag, finish flag, SYN flag, ACK flag. Okay, Windows size, and the optional data and the checksum also. Important is the checksum, which is the signature. So we can do the header analysis to know that if the packet is coming from a genuine user or not. Okay, so and log analysis after getting inside the network. Okay, inside inside the network we can do the log analysis. Now any doubt here? We are done with the topic. This DOS attack.
Sir, sorry, can you repeat egress or ingress?
See, this is my network. What packet? Okay, what kind of data? What kind of data could come in? Okay, this is known as ingress. Okay, ingress filtering. And what type of data could go outside the network? It is known as egress. Okay,
Okay, sir.
what kind of data? Let me write it. Kind of data entering the network. Okay, what kind of data going out of the network. See, both are important because we don't want any traffic or any data entering into our network, okay, private network, from any attackers, okay, from any attacker's address, and we don't want any insider data, okay, inside data or inside packet to go to outsider attackers, okay, to the attacker's address. So at both point uh, we need to save our packets, okay, save our data
Yes, sir.
by following into wrong hands. Okay. So now, any doubt here? We are done with the lecture, Mr. Deep.
No, sir. Thank you so much.
Anyone having doubt? Please let me know. Are we clear with the topic?